Yeah. So today I'm going to talk about multi-tenant frontends in general and with some specific examples from what we have been building at small case and my experience with building SaaS apps at small case. Uh, some quick things about me. I live in Bangalore. I work at small case. I live with my wife, my dog, and my baby. And some of the things that I'm currently interested in are accessibility, front end architecture patterns, design systems, general standardization, reusability, and workflows processes within teams and within front end. On the right hand side are my social handles. Cool. Just setting expectations for this talk, what you should be expecting and what you should not be expecting. So, like, since it is going to be a short talk, like about 25 minutes is where I would want to keep it at. And I would not assume any familiarity with a multi-tenancy. So, in general, this talk would more be about an overview of what multi-tenancy is, and it will also give you an overview of some common challenges faced while supporting multiple tenants, but like across the span of the whole stack, not only with respect to the DB or the API or the backend, but more in context of front end and code base and development and things. Uh, Also, I think like a lot of you, if you have been working with SaaS applications, you might be doing a lot of these things without even realizing that you are building multi-tenant front ends or multi-tenant apps. So this talk would probably help you structure or formalize your thought process around that, and maybe like it will allow you to research things better because now you would be able to put a name to what you're doing. What not to expect from this talk? So this talk is not going to be in depth about anything. We are not going to talk about a lot of backend things, which I like DB or even infrastructure or API or services. This talk would also not cover all the use cases in the wild about front end architectures because, like, with the advent of SaaS apps, you would see that there are a lot of different patterns that everyone is using. And this talk would also not talk about the exact technical implementation of things, like in terms of how to enable something in React framework or how to enable something with AWS stack or anything like that. It will be more general. Moving ahead to overview about what exactly is multi-tenancy. So multi-tenancy in simplest terms is like supporting multiple customers in your application. I think every one of us would have worked in some application which would be used by more than one customers. Now if you have a B2C application, those customers would be your users, but if you have a B2B 2C application, your customers would be the businesses. Now, even if you have a B2C application which supports multiple users, that itself is a multi-tenant app. But like those challenges or challenges related to architecture of those applications have already been solved and are generally a known pattern. But supporting multiple businesses has like some unique set of challenges just because of the stakes that are involved and also the kind of architecture that you need to provide to your uh, business customers, or like these are what we are calling tenants throughout this talk. So like why is a multi-business thing different from a multi-user thing? Because like with when you do a multi-business application or uh, you would need to get into a contract, you would need to take care of security because there would be compliances regulations on those businesses, you would need to ensure high availability and a lot of things. So like the overall stakes are much higher than a B2C application, and also like these businesses are going to pay you a lot while like end users may or may not be uh, that much involved in the commerce of your application. Cool. So in general, what we are going to talk about is how to support multiple tenants. Now, supporting multiple tenants can happen through two patterns. One is single tenancy, another is multi-tenancy. So, like, I mean, you can actually just support multiple tenants using a pattern called single tenancy as well. So, we'll quickly go through what is single tenancy and what is multi-tenancy, and then we'll move forward to challenges. So, just single tenancy is when there is a completely separate instance of the application plus the infrastructure for each individual tenant. So each individual instance of the application and the infrastructure is physically separated. So you can like think of it in terms of some application which you install on the client site itself, like they have their own cloud. You just like install that application for them. While multi-tenancy in general in strict terms is like when one single application instance serves all the tenants, and like there is no physical separation, but there is still logical separation between tenants. This is what most of the SaaS apps today are doing. So some examples of these apps would be Slack. Like Slack is something which supports multiple tenants, so you would find smallcase.slack.com or yourcompany.slack.com or other things. Similarly, like we at Smallcase are building a lot of such multi-tenant SaaS applications. Then any other business, they would, if they are a SaaS business, I think in most cases they would be building a multi-tenant application. So if you have worked with like Fresh Team, I think Fresh Team is again a multi-tenant application. Postman is a multi-tenant application. So a lot of examples in the world. Cool. So like in general, multi-tenancy and single tenancy is talked about or differentiated based on the infrastructure and the DB. As I said that like there is a separate instance of the app plus the infra, which means there is a separate DB for each tenant. There is a separate ALB for each tenant. There might be a separate CDN for each tenant and whatnot, right? And that generally makes sense. You will find a lot of articles about it because there that is where all the security or the availability or isolation concerns come in, right? But in this talk particularly, we are not going to talk about these concerns. We are actually just going to talk about what are the other auxiliary things which are involved when you are developing a multi-tenant application. So things like what would be the ideal team structure, what would be the code base organization, what would be some component patterns that you can use, what kind of like how your tech stack impacts what kind of multi-tenancy you would choose, or in terms of business, who has more control, the tenant has more control or you have more control, which will help you decide how you would enable multi-tenancy in your application. And all of this would more be in context of front end plus the front end infrastructure. So expect nothing from the DB or services side. Cool. So this is a quick comparison between single tenancy and multi-tenancy. So by now you would have understood that single tenancy is where like there would be one single instance. So it can be an on-site deployment. It can also be cloud-based, but like that would be specific to the tenant. Multi-tenancy, on the other hand, is completely cloud-based SaaS applications generally. Single tenancy is arguably more secure as your tenant data is isolated. There is no way that someone else can just breach this data because some other tenant has been breached. While on the other hand, data in multi-tenancy is logically isolated but physically co-located with other tenants. So it means that you might be using the same DB with different tables for each tenant, or you might be using the same table for each tenant, but like they are just logically separated by a primary key. Then with single tenancy, maintenance is costly because you have your own instance of the application. There has to be some kind of maintenance. Generally, you would get into a service contract with the provider to actually get their people to help you with maintaining this application. On the other hand, multi-tenancy is like hands-off maintenance. It is completely maintained or managed by the SaaS provider. Single tenancy has physical separation, multi-tenancy has logical separation. Single tenancy has isolated backups, so there is quick disaster recovery. Multi-tenancy has shared backups, and like if something goes down, it will probably go down for all the tenants. But then, like with the robust cloud infrastructure that everyone has nowadays, this is generally not a problem. Then single tenancy can provide you more control or provide the tenant more control and potentially more customization because you have the like application instance completely to yourself. So the developers or the SaaS provider or the application provider does not really think about what impact this change is going to have on other tenants. They can just build it for you. Obviously you will need to pay more, but I mean you have more control. With multi-tenancy, generally there is less control because all the customizations that need to happen would impact the other tenants in some way or the other. But on the other hand, updates are quick. So if there are some security updates that are required, it will go to every tenant all at once. Similarly, single tenancy has more availability or more dependability just because it is isolated. Multi-tenancy, other neighbors can actually uh, impact how your application is working. So if there is one single shared server for all the tenants and one of the tenants has high footfall on a particular day, it might lead to slowness for the rest of the tenants as well. But like these are also solved problems, and with the robust cloud infrastructure, I think this does not really happen. This is like more theoretical. Then single tenancy major problem is there is less efficient utilization of resources, and which is why it is costly. Multi tenancy you can share your resources, which is why there is more efficient utilization. One thing to note in single tenancy versus multi tenancy is like you don't really need to share your code with the tenant, right? So you just share the instance of the application, so the code is still owned by you, right? In both single tenancy and multi-tenancy, it's not like you provide them the code as well. Cool. So, like strictly talking about multi-tenancy, I think we have discussed that it is more discussed in terms of the infrastructure stack or on the backend side, but just extending that definition to include a lot of other things. So, like multi-tenancy can generally have implications in any part of the stack, like code base, build, services, DB, CDN, your load balancers, and other pieces of infrastructure. So, like you can, some examples, you can have individual builds for each tenant, but each of these builds are simultaneously running in one single server. You might be sharing the same DB but different tables. You might be sharing the same DB, same table, same schema also, and just differentiated by a primary key or the tenant name or the tenant ID. You might have a single build but different CDNs, CDN distribution for each tenant. There might be like a single build or a multiple build, and there would be different EC2 servers serving to this. So there are a lot of options, which means that every part of the stack somehow contributes to multi-tenancy, and like there is no black or white definition of when something is multi-tenant or not. So that is not the point of discussion today as well. Like we are not going into the strict definition of what multi-tenancy exactly is, but we are going to discuss how to enable multiple tenants or multiple customers in your app. So just furthering this point, I think taking inspiration from the ship of thesis, I think, like look at all of these examples and think about when does a app stop being the same application, right? So like one of the examples is you have single code base, single build, single deployment, single CDN, and that is your app. You can still support multiple tenants here. Then you might have multiple builds, multiple deployments, multiple CDN, where you have one single code base. Now this again is also the same application because it is providing the same functionality to all of its tenants or all of its users. Similarly, you can have multiple builds but a single server and multiple CDNs on top of that single server. Similarly, you can have multiple code bases where each code base is per tenant, and multiple builds, single builds, or a lot of these combinations. But like I would personally call all of them multi-tenant because the final functionality that the application is providing is can be recognized as one single functionality that the application provides, and all of this complexity is hidden behind that final instance of the application. Uh, cool. So that was more of an overview of what in general multi-tenancy is, or how multi-tenancy differentiates with single tenancy. Now we'll quickly go on to the challenges that you might face when you're implementing multi-tenant code or developing a multi-tenant front-end application. So the first challenge is how do you identify tenants? Uh, so for identifying tenants, there are two broader ways. One is you can have separate builds for each tenant, with in which case you will already know at build time what is the tenant, and based on that you will create some individual build for that tenant. But obviously, even just hearing that, you would know that it is not the most optimal thing to do, because if you have 150 tenants, why create 150 builds for them when you can just have one single build? And identify the tenant at runtime. So identifying the tenant at runtime generally depends on the URL. So you can have domain-based multi-tenancy, subdomain-based, path-based, query param-based, any part of the URL basically, even hash also. So there are some examples that I mentioned about how the URL would look like if you were to identify the tenant information from the URL. But like for some use cases where our application uh, does not directly depend on the URL, you can use other ways also. Like for example, you can send this information in HTTP headers if it is a server rendered application. Maybe from the like initialization point, you can just send this information in headers, or you can not change the URL, but whenever the user logs in, you know which organization they belong to, so you just customize everything for that user for that organization. Or any other communication patterns like post message. If your application is an iframe, then the parent application can just provide the tenant information in post message. So any communication patterns work based on uh, what what kind of requirement your application has. So we'll also look at like how do we figure out which method for identifying tenant to use. So one of the major things is different methods have different infra requirements and would lead to different costing. So if you are going to have a domain based multi-tenancy, which means that the top level domains would be different, which means that you need to have a like uh, certificate for all of those top level domains. You would need to have a route 53 entry or a DNS entry for all of those separate domains. You would possibly need a separate CDN distribution for all of the top level domains, because it is not very easy to actually set up a CDN uh, across multiple domains with the same caching policies. So this is like one thing that will impact your decision. Another thing is the tenant branding that needs to be conveyed to their users. So like it might depend on the contract between you and the tenant, but maybe you can have something like app.com/tenant1 versus tenant1.app.com. Like this tenant1.app.com has more visibility for the tenant branding, and app.com/tenant1 looks like it is your app and there is some space for the tenant on your app. So this can be another factor based on which you can determine which one to use. Third thing is who owns the application, you or the tenant. So in some cases, like you are the application provider, sure, but your integration with the tenant is done in a way that your application is just an extension of the functionality they provide, and each individual tenant legally owns that application, right? So in those cases, uh, it wouldn't be possible for you to actually use anything other than domain based multi-tenancy, or at least like there would be some abstraction which will finally lead to domain based multi-tenancy. Similarly, how the user would land on your application, uh, uh, are they supposed to land on the URL directly, or like is this application just a iframe application which opens from within a parent where the URL is not even visible to the user? Based on that, it also impacts which method you would use. Another thing that would impact this decision is where in the application life cycle do you need to identify the tenant. So like in general, if it is, let's say, taking the example of the iframe application once again, if it is uh, initiated by someone from their own website, like the tenant website, and the user does not need to see the URL, then the only place where you need to identify the tenant is when the application initializes, because every this information can then be kept in the browser memory or the application memory, and like you are okay for the rest of the application lifecycle. But if it is a server rendered app and it is a possibility that some user action might trigger another server rendering, then you need to have a way to actually persist this information or to get this information from the URL, right? The next thing is customizations. What kind of customizations you can expect for tenants? So customization depend on the kind of integration you have with the tenant. One general pattern is you have your application which already has all the functionalities, and the tenant want to integrate with your application so that they can extend your functionality to the users, right? In this case, you have more control because you create the features, you implement the features, and the tenant can just integrate with those features, right? But there is another type of integration where you actually depend on the tenant functionality uh, to provide some functionality to your users, which are like finally the tenant's users. So in that case, the tenant has more control because, like just giving you an example, let's say you are creating a loan application which integrates with the existing bank's system, and you need to provide the loan functionality to your users. Now, since all the existing banks implementation of the loan functionality would be different in terms of what kind of loans they provide, what kind of duration they provide, what kind of interest rate they provide, so you will actually need to customize your application code to cater to all of these cases. You cannot just go to every bank and say that, okay, I want to provide loans only for these periods, so please make changes in your application code to only allow these kind of loans, right? So in those cases, you will actually have to maintain one component per bank for the loan thing, right? So there the tenant has more control. General customization that you can expect, custom components with custom UI or logic for each tenant, the same example that I just gave. Custom JavaScript functionality for each tenant based on their exposed and API interface. So like again, if you need to integrate your application within the tenant mobile application and they already have some methods exposed for integration, then you may or may not be in a position to say that, okay, we are only going to respect certain method names and not the others, because like again, if you are using the tenant functionality to extend it to your users, you have to agree to their existing interfaces. Similarly, a very common use case is to just customize UI strings, whatever is shown on the UI. Another requirement that we have seen in the wild is that every tenant wants to integrate some kind of logging or analytics which is specific to them. Then feature flag for sure you are going to have, because feature flags is the core of how you enable or disable certain functionalities or customizations for the tenant. Every tenant or each tenant might require some kind of theming capabilities and more. So these are some general customizations that you can expect based on who controls the feature development of the application more, the tenant or you. Next, we'll talk about some code based organization patterns and development. So, the main thing here is feature oriented versus tenant oriented, which I've already explained in a way. Like, uh, if you control the features, if you implement the features without depending on the tenant functionality, and the tenant just integrates with you to expose your features to their users, it is more of a feature oriented thing, because you don't really care about tenants and how many tenants are going to integrate with your application, because you do not have any dependency on tenant side functionality. On the other hand, if you have a dependency on the tenant side functionality, like the loan example that I just gave, you need to have a tenant oriented development where you will need to customize a lot more than feature oriented development. So for code based organization, I think for feature oriented development, there is not a lot of problems that you would face, because you can just have a single code base with slight modifications to your components based on some feature flags, and like you can just use a runtime config for customizations, right? But with tenant oriented development, you would probably need to make this decision at build time, because you have 70 components which are customized for each of the tenant. It is like very difficult for you to identify at runtime which of these components to load, and even if you load them, like they should be compiled bundles of javascript code. You cannot like compile them on the fly. So generally, like the easiest thing here to do here is to just have a compile time uh, multi-tenancy, where you will have separate builds for each of the tenants. Then, talking about builds, deployments, and infrastructure in general. So, like if you choose runtime customization, where you will get the tenant config from an API call at runtime, you can just have one single build for all the tenants, because there is nothing that changes across tenants for those builds, right? Because all the customizations are happening at runtime. So, like in those cases, for a single page application, you can just have one single build. You can just put it as a static hosting somewhere. For a server-ended application, you can just have one server which can horizontally scale for tenants, but there does not need to be a tenant-specific server. On the other hand, if you choose build time customization, then you have to create multiple builds and have to do multiple or individual deployments for each tenant. So like each individual deployment in case of SPA can go to their own S3 buckets for static hosting, or for SSR each tenant server might be deployed individually, or like you can still have multiple deployments in a single server also. Uh, Similarly for deployments, I think just extending from the previous point, generally you would, if you have an SPA, you can just like deploy it all together because it is static hosting. If you have SSR, you just need to make another decision about how you would scale the server, or how would you make sure that there is one server which can cater to all the tenants. But like in this case, there can be some performance problems that you will face, which is like separate. If you have separate deployments because you have separate builds for all the tenants, then if you have more than 100 tenants, for example, then every time you do a release, you will need to create 100 builds. You'll need to do 100 deployments, which can easily take 1 hour, 2 hours, which means like rolling back to a previous version of the application again is costly, because it will take 1 hour or 2 hours. So like generally, I think we have figured out, if it is a feature oriented development, let's just have one single build and one single deployment. If it is a tenant oriented development, uh, cannot do much. We have to create multiple builds and have to do multiple deployments. Then, in terms of infrastructure, some of the questions that you would need to answer: does each tenant need its own different caching policies? With feature oriented development, not so much, because I think those kind of customizations are generally not possible. But with tenant oriented development, you might have some different routes altogether in your application for different tenants, which might need some different caching policies across tenants. So sure, you would probably need some different caching policies. Similarly, like do you have one single CDN, one single server which can serve all the tenants, or do you need multiple instances of those? Do tenants need their own domains for hosting the application? This is like domain based multi-tenancy, and if the tenant owns the application, they would want you to just host the application on their URL, not on your URL, right? So that also changes some part of the infra decisions that you can take. uh, in our case, for example, there is a tenant oriented development code base where out of 15 tenants, there is like one or two tenants who actually host the application on their infrastructure. For the rest of them, we host it on our infrastructure. Or uh, how do you scale for individual tenants is another question that you have to ask. If there is just one single server for all the tenants, then Like how would you make sure that a particular tenant users are not going to uh, impact the users of the other tenant. There are some other smaller concerns that you will face as well. Some of them I'll just quickly go through. How do you deploy maintenance mode for individual tenants? So like you just have one single build, one single deployment. So how do you make sure that one tenant for some reason needs to go into maintenance mode? How do you do that? So like you can solve it using multiple things. You can solve it at the CDN level, or you can just solve it through config if it is a runtime based multi-tenancy. With customized builds per tenant, this is not a problem, because like you have different deployments, so you can go to each one and just put in develop to the maintenance mode. Another concern is like if you have a error tracking software and if you have multiple builds, then the same error would appear in across all of the tenants. So how do you like have workflows around making sure that uh, all the tenants can have that error resolved if you resolve it for one tenant, like on the software, not on the code. In the code it would be resolved because there is one single code base. Similarly, there are some concerns related to testing. So if you have separate builds for each tenant, you would need to test each build individually, because there is no other way that you can make sure that all of the builds are working fine. But if you have one single build, then you can just test different combination of features. This is more useful in feature oriented development. If you have multiple builds, then like how do you maintain dev staging environment for each tenant? Let's say if you have 15 tenants, do you have 15 dev environments? Do you have 15 staging environments? Or like do you test tenants one by one in just one environment? You deploy the first tenant, deploy the second tenant, deploy the third tenant. Or like in case of code base, how do you make sure that you can write or maintain test cases per tenant, because it is a single code base. And like if it is a feature oriented code base, then you probably do not need to write tenant specific test cases. But if it is a tenant oriented code base, then you need to have test cases per tenant. So how do you write them in code? Feature flags, again, I've already talked about, is one of the core things that you would need to have if you want to have any kind of multi-tenancy. So for this, like generally we are just using our own implementation of build time feature flags and runtime feature flags, but there are some frameworks out there which you can also look at to help you with this. uh, Another smaller concern is team structure. So like in tenant oriented development, if you have a lot of customizations that need to happen for every tenant, you might choose to have one team per tenant, like one small dev team per tenant, and one team which is taking care of the common code base. While if it is a feature oriented development, generally it makes sense to just have one single team which looks at everything, because that team does not really need to know about every tenant, or there are like customizations across tenants, because they only need to care about customizations in features, and that the product can control. Similarly, tech stack is another consideration. If you have an iframe application, it will change a lot of things in terms of how what strategy you choose for multi-tenancy. If you have a SSR application, it will also impact the strategy. SPA is generally the easiest, generally the simplest, because like you can just keep the tenant info in memory, and like you can just read it at initialization and just keep in browser storage. So generally the easiest implementation. Another smaller concern is how do you scale tenant onboarding? So let's say right now you have 10 tenants, but you are expecting 100 tenants to come tomorrow, or like by the end of the year. Then you are not obviously going to manually create everything for each of the tenants. Like you are not going to manually create all the infrastructure. You are not going to manually create new folders in the code base for that tenant. You are not going to manually maintain all of the tenant specific configs. So there has to be some kind of a control center or a CMS where someone from the either the tenant team or from your team can control things directly without going into the code base or without needing a separate deployment, right? So all that said, I think I'll just quickly walk you through some of the multi-tenant front ends that we have at small case, and like how they are implemented based on whatever decision making criteria we have discussed till now. This should be quick. So the first one is gateway. It is an iframe app. It does not need to be directly reachable from URL. So we use query param based multi-tenancy because it is a single page app. So we don't need to have different like caching infrastructure for tenants, or we can do with query param based multi-tenancy, because even if we get the query param at the time of app initialization, we can just store it in the memory and we can just read it from the memory, because no one is going to reload the iframe, or no, there are no links to get outside of that iframe, right? So this is very easy. So uh, this one is feature oriented development, because like we provide the features to our tenants, and we do not depend on anything from the tenant side to actually implement our features. This has a runtime configuration which is fetched from DB based on tenant identification from the query param. This is a single build, single deployment. The only major issue with this is like the SDK that manages the iframe lifecycle. Like this application has to be opened by someone, and we provide an SDK to the partner to just call SDK methods which will maintain or manage this iframe lifecycle for them. So that SDK, since it lives inside the tenant website, not inside the iframe, so there are some concerns around how we can have our own tracking or analytics implemented, which does not disturb whatever is already there on the tenant side. Then the other front-end multi-tenant code base that we have is publisher microsites. So this one has subdomain based multi-tenancy, and again feature-oriented development because we provide all of the features and tenants just integrate with us. This again is a single build, single deployment. We chose to do this as an SSR tenant. Since it is an SSR, the tenant needs to be identified throughout the app lifecycle because there can be server side requests as well where you would need to send the tenant information, which is why we chose subdomain based multi-tenancy. This one needs to be directly reachable by URL. Another reason to have URL based multi-tenancy. Tenants can customize things like text strings or switch on or off some features. They can also change some branding about their photos, their names, and things like that. And we use a runtime configuration based on tenant identification. This code base also has a control center where some part of it is exposed to the tenants where they can just come and change things, and it just re-triggers the deployment of one single build, and changes are available immediately. There is another code base called the distribution module where we again have subdomain based multi-tenancy. This is again a single build, single deployment, but this one is an SSR plus iframe, and in the future it might be directly reachable from the URL as well. So we went for a subdomain based multi-tenancy in this case. Since it is an SSR, tenant needs to be identified throughout the app lifecycle because, like any SSR request, we need to have that tenant information passed on to the server. This is a feature-oriented development. Tenant can just customize some of the functionality by feature flags. It again, since it is a feature-oriented development, we could afford to have runtime configuration. The final code base that I'm going to talk about, which is slightly different from all the rest of them, is the broker platform. The links to that, you might say this is like the main small case web platform. So here we have domain-based multi-tenancy and we have tenant-oriented development because we need to use the tenant functionalities to actually build our functionalities on top. For example, if the tenant does not have a way to do an SIP in stocks, it is very difficult for us to build that functionality because we use their functionality to build our functionality. So in this case, if different tenants have different implementations for how they do or how they allow SIPs, we need to have a specific code or specific component for each of the tenants to make sure that we can cater to their specific implementation. In this case, I think again there are some tenants which own the part of infrastructure because they own the app legally. Like if you see the URL is smallcase.zerodha.com, not zerodha.smallcase.com. So like it is their application, they own the application. Just that the product and the software is provided by us. And in most cases, the infrastructure is also provided by us, but there are some tenants who choose to host the application on their side. This one has multiple builds because this is tenant oriented, so we need to have a build time multi-tenancy, so separate build for each tenant. And if there are multiple builds, it leads to individual deployments, which means that we actually test for 15 different tenants at a time whenever we do a deployment. And how we have implemented this in the code base is that there are multiple ways. We could have used a monorepo to host the code for each individual tenant in their own repo, in their own repo, and like we could have just had the common code in its own repo as well. But we have currently chosen to just keep everything inside the same code base and within multiple folders within the same code base because like the one single team works on everything right now. The final thing is like in this case, since it is a domain based multi-tenancy, we need to have different CDN distributions because caching is generally based on URL and it is very difficult to implement it otherwise. And in some cases, since the infrastructure is not owned by us, we cannot anyway have a CloudFront or any other CDN in between. It is for the tenant to take care of. So like this was a quick introduction of uh, most of the things that I have learned by building SaaS applications at Smallkeys. uh, as some of the next steps, I think since I already knew that this would take around 30 minutes or so, even at the speed that I'm speaking, I think I would say that any follow up questions you can directly mail me or you can ask me on Twitter. I will try my best to answer. Another thing is like this talk is going to be very soon converted into a blog post, which will have all of the details that I talked about and which are not on the slides. So that I'll post on Twitter as well. The link to slides, I think, yeah, I'll post on Twitter as well as in the comment section here. We are hiring at small case, so in case some of you find this interesting, there are a lot of other similar challenges that we are solving at small case. Please feel free to reach out to me or anyone else at small case if you are interested in an opportunity. Yeah, I think that is it. Thank you so much